All right, so today we're going to practice identifying what the horizontal and vertical asymptotes are. With these examples that we're taking a look at today, these are some very extreme examples. As you can tell, both of these have quartic, right, to the fourth power polynomials, right? And what they do, it's nice, very nice of them, is they factor it for you. So they give you the original polynomial, and then they give you the factored form here underneath. So we're going to use that to help us identify our asymptotes. Okay, so you probably don't have this exact one right now. This is some students. So I just want everybody to look at the shared screen right now. I'm going to show you how to do it, and then I'll let you guys play around with it yourselves. Okay, so there's a few things that we have to remember from yesterday. Our vertical asymptotes, they come from the denominator, right? They come from the zeros in the denominator. So that's one thing we have to worry about. We get a whole if we have a removable discontinuity. So if any of our denominator factors match up with our numerator factors, they get eliminated, and that becomes a whole instead of a vertical asymptote. We had our special rules about horizontal asymptotes. If the degree of the numerator is greater than the denominator, it's automatically y equals 0. If they are the same, like this one, we take a look at the leading coefficients. All right. We haven't gone over slant asymptotes in depth yet, so don't worry if you get that. So here's what you're going to do. So we're going to enter vertical asymptotes. So if you think there are vertical asymptotes, you're going to click on the enter a vertical asymptote. A little box is going to come up. It says x equals. All right, so let's take a look at our denominator. Well, our first term is 2x. Well, 2x, if we set that equal to 0, well, then x equals 0. So you type in 0. Oh, well, that was wrong. Okay, because, well, look here. I have an x in the numerator and an x in the denominator. Those would eliminate each other, and that would actually be a removable discontinuity. So a whole at 0, and you can press the check button down here. Okay, that makes sense. Now, be careful. If you press the check button, you can see, like we did here, it's going to give you all the lines. So maybe wait off on that until the end. So next we have x minus 1. So x minus 1, oh, well, look at that. That's also in the numerator. So that's going to be another whole. So x equals positive 1. You could click the enter a whole button again to double check, and there you go. You get a check mark there. Then we have x minus 1. I'm sorry, x plus 1 in the denominator. There's no x plus 1 up here, so that would be a vertical asymptote. So if x plus 1 is a factor, then x equals negative 1 would be a vertical asymptote. Click that again. Okay, there we go. That checks out. And then the last one we have here is x plus 4. There's no more x plus 4s up here, so x equals negative 4 is also a vertical asymptote. And look at that. That's what we have here. Now this horizontal asymptote. Well, we look at the coefficients for my leading terms. In the numerator, it's a 1, and the denominator, it's a 2. So there is a horizontal asymptote at 1/2. Now that we think we have everything, we can check, and yes, it is in fact. Now, there are two things that I want to say before you guys start trying this on your own. In this particular example, we do have a case where the line crosses our asymptote. Okay, here's our horizontal asymptote, y equals 1/2. Now, this is a kind of special property that you'll see pop up once in a while. It's kind of like a rebound. So here, our graph bounces underneath it, but as we go this way, it acts like an asymptote that it will never go back above the asymptote line. Okay, and then on the left side, if we follow this part of the graph, that behaves like a normal asymptote. Now, the reason that this happens over here is because we have a few removable discontinuities, right? So after we remove the discontinuities, that changes our function. I want us to take a look at one example. Okay, here I have x squared minus 1 over x minus 1. Well, this is a rational function, and, by our definition, we should see some asymptotes. But what happens is x squared minus 1, we can break to x plus 1 times x minus 1. And we're going to put all that over. Don't worry about that right now. So with these two, okay, I have that removable discontinuity. So the equation that I'm left over with is just a linear x plus 1. Okay, and if I remove that, we can see that those two are the same line. Now this one, this red line, is going to have a hole at x plus 1 because we removed that discontinuity. All right, so when we have that removable discontinuity, some funky things happen, and we may see an instance where we cross the asymptote. All right, so now you guys are going to try it. I'm going to check in on you. When you're done, or if you think you're done, you just press the new function button at the bottom, right? And you get a new function. If you get one, let's see, and that would be good. If you get one that looks like this, where it's not a perfect parabola and it's kind of like lopsided, that usually means you have a slant asymptote. Okay, so you can skip those ones because we haven't gone over that. But something like this, okay, use your skills that we did, all right, and we can find our vertical and horizontal asymptotes. All right, so go practice that for a little bit. I'm going to check on you guys. Whoever was student 3, sorry if I messed up your stuff. All right, so click on the link in class or go to geogebra.org/classroom and type in this. And yeah, let me know if you have any questions.